This is problem number 3. It says a rectangle has a perimeter of 28 units and an area of 48 square units. The sides are either horizontal or vertical, so they need to be left and right and up and down. If one vertex of the point is -5, -7, and the origin is on the interior, we need to find the vertex that's across from that point. So what it means by the origin is on the interior is that the origin has to be somewhere inside our rectangle. It can't be outside of our rectangle. It has to be somewhere inside. It doesn't matter where, it just needs to be somewhere inside. So I have this point, -5, so I'm going to go 1, 2, 3, 4, 5 to the left, and down 7. 1, 2, 3, 4, 5, 6, 7, which is this point right here. Okay, and our perimeter has to be 28, and our area has to be 48. So I'm going to come up with all of my different possible lengths for the sides and figure out which one is going to give me that correct area. So over here on the side, I'm just going to write out all of my possible choices. I could have side lengths of 1, and remember rectangles have 2 sides that are the same. And in order to get this to equal 28, I need 1 plus 1 makes 2, so I need 26 more to get to 28. And since they both have to be the same length, each one would have to be 13. So 1 plus 1 is 2, plus 13 makes 15, plus another 13 makes 28. Another possible option is for 2 plus 2, which is 4, and that leaves us with 24 left over. If I split that into 2 equal pieces, they both have to be 12. I could also have a side length of 3. 3 plus 3 is 6, so I need 22 to be left over. And if I split that along 2 sides, each one would have to be 11. 11 and 11 make 22, and then I add 6 more to get to 28. I could use 4s, and you might start to notice a pattern. 10 plus 10 is 20, 4 plus 4 is 8, and 20 and 8 combined make 28. So I'm just going to keep going down my list. 5 plus 5 and 9 plus 9. Then we've also got, 6 plus 6 and 8 plus 8. And we'll go 7 plus 7 plus 7 plus 7. And if I wanted to go to 8 down here, I would need to use 6s, which are already up there. So there are all my possible opportunities or options for the side lengths. If I had a side length of 1 and 13, the area would be 13, because 1 times 13 is 13, not 48. I'm looking for an area of 48. If I use the side length of 2 and 12, that's an area of 24, because 2 times 12 makes 24. In this one, I would have 3 and 11 as my side lengths. If I multiply them together, 3 times 11 is 33, but I'm looking for an area of 48. How about 4 times 10? 4 times 10 is 40, that's not 48. 5 times 9? 45, that's not 48. 6 times 8? Ooh, that one is 48, but let's check 7 and 7. 7 times 7 would be 49. So the only possible option that I have is this one right here, which is the 6 and the 8. One of my criteria said that the origin has to be in the middle of my triangle, or in my triangle somewhere. So what if I went up by 6? Let's count together. 1, 2, 3, 4, 5, 6. Am I going to get the origin in there if I do that? No, it's going to be outside, too high above it. So instead of having 6 as my height, I need 8 to be my height. And then I'm going to have a width of 6 instead of a width of 8. So 1, 2, 3, 4, 5, 6. And same up here. 1, 2, 3, 4, 5, 6. The question was asking me, where is the vertex that is opposite of this corner? And so opposite would be this one up here. And we need to list the coordinates of those points, which in this case is 1, 1. It's right 1 and up 1.